All right, hi folks, this is Larry Mussolino. I'm recording a video for Module 3 in Math 181, and I wanted to go over with you a couple of the starting points for game theory. And let's do a couple of WebAssign examples, and I also wanted to discuss with you the discussion board on setting up an expected payoff. All right, so we'll come back to Module 3 in a minute. We're going to construct a payoff matrix. We're also going to come up with an expected payoff for a two-player game. So let's do that. But before we do that, I'm going to go back to Module 2, and I want to go over with you the basics of multiplying two matrices. Because when we work through the game theory examples in a few minutes, we need to know how to multiply matrices. So let me come down here and talk about how to do that. First, let me mention to you the dimensions of a matrix. So the way we write this is we look at the number of rows and columns in the matrix. So if a matrix has 3 rows and 4 columns, we would write it as 3 by 4. If a matrix has 4 rows and 2 columns, we would write it as 4 by 2. So we always put the number of rows first and the number of columns second. Let's say I want to multiply matrix A times matrix B. Well, before I can do that, I've got to check and make sure the dimensions are appropriate for multiplication. Here's how to check. Write down the dimensions of matrix A. Let's say they're 3 by 4. And then write down the dimensions for matrix B. Let's say that's 4 by 2. These two middle numbers must be the same to allow the multiplication to happen. If these two middle numbers are not the same, you're not allowed to do the multiplication. Let me give you another example. Let's say we had matrix C multiplying matrix D. And let's say matrix C was a 5 by 3 matrix, and matrix D was a 4 by 2 matrix. Notice these two middle numbers are different, right? These are not the same. Well, if they're not the same, then this multiplication is not allowed, so we cannot multiply this example. All right, but what if these middle numbers are the same? What I'd like to know is, what does the answer matrix look like? Well, you figure out the dimensions of the answer matrix by crossing out these numbers here in the middle, and the resulting numbers tell you the answer matrix. So the answer matrix here would be a 3 by 2. So our answer is going to be 3 rows, 1, 2, 3 rows, and 2 columns. 2 columns. This is what our answer would look like. Now, when you go into WebAssign and you enter a matrix in WebAssign, you've got to know the number of rows and columns before you get started, because you've got to tell WebAssign how many rows and columns you want to create in the answer matrix. You might notice there are these green arrows, and you select these green arrows to either add or subtract rows or columns. All right, so now let's talk about multiplying matrices. How do you actually do the multiplication? Well, let me scroll down so we could do an example here. Let's come down to this example right here. So we're going to take, bear with me a second there. All right, we're going to take this matrix, let's call this matrix A here, and we're going to multiply it by this matrix B there. First, let's check if we're really allowed to do the multiplication. Well, matrix A is 1 row and 4 columns. Matrix B is 4 rows and 3 columns. I'm noticing these two middle numbers are the same. Okay, and I know our answer matrix is going to be 1 by 3. All right, so our answer matrix is going to be 1 row and 3 columns. So let's explain how to do the multiplication. All right, I know our answer matrix is going to be 1 row and 3 columns. So here's our answer matrix. We need a number to put in each of these boxes. to come up with the answer. It's 1 by 3. All right, here's what we do. To get started, we take this row and multiply it by this column, where we multiply corresponding entries and then add those results together. So let me show this. I'm going to multiply row 1 by column 1. If I do that, it's going to be 2 times 1. I'm taking this 2 and multiplying it by that 1, plus 0 times 1, plus negative 1 times 0, plus 3 times negative 3. Now I'm just going to work this out. This is 2 plus 0 plus 0 plus negative 9, negative 7. That's the answer to put in this first cell, negative 7. Okay, so that first cell was taking row 1 times column 1. I've got to multiply the corresponding entries. So I take the first entry in row 1, multiply it by the first entry in column 1. Then I do the same thing for each of those entries and add the results together. All right, let me do another example. Let's take row 1 and multiply it by column 2. All right, I'll do it up here. Row 1 times column 2. All right, so I'm going to start out with this. Let me erase what I did here to make it a little easier to see what we're doing. Okay, so now we're going to take row 1 and multiply it by column 2. All right, I'm going to start off by taking 2 times 1, and then 0 times negative 6. All right, plus negative 1 times 5. Notice I'm taking each row entry times its corresponding column entry. And the last multiplication here is this 3 multiplies the 8. And now I'm going to add all these results together. Let's see, this is 2 plus 0 plus negative 5 plus 24. And I think that works out to be 21. So I'm going to put that answer here, 21. So that was row 1 times column 2. All right, let's do the last entry. So the last one is I'm going to take row 1 times column 3. Okay, I'll do it down here, row 1 times column 3. All right, so I'm going to take 2 times negative 8 to start. All right, then I'm going to take 0 times 0. Then I'm going to take negative 1 times 2. And finally, I'm going to take a 3 times 1. All right, and I'll work all this out. This is negative 16 plus 0 plus negative 2 plus 3. What is that? Negative 18 plus 3. Looks like it's a negative 15. So negative 15 goes here. So this was row 1 times column 3. Okay, so this is the setup for multiplying matrices together. It's a little complicated until you get the pattern. And once you get the patterns down, it's really just basically simple multiplication. Folks, please watch a video on this. So if I come down here, here's a good Khan Academy video on doing the multiplication. There's also some examples worked out in the textbook, okay? All right, so now let's go to Module 3 and talk about setting up a 2-player game. And really what you're going to end up doing to set this up is create matrices. And then when you want to figure out a payoff, you're going to multiply matrices together. Okay? All right, so the first thing we're going to need is a payoff matrix. So a payoff matrix is basically a matrix that decides what payoffs result from some combination of events. So here's an example. If you read this example here, it's going to give you a game that involves payoffs. So here it is. Let's say you flip a coin, and player A will either choose heads or tails, and player B also chooses heads or tails, and then you flip a coin. So if player A chose heads and player B chose heads, then player A wins $5. If player A chooses heads and player B chooses tails, player A loses $2. So when I go to set this up, I'm really thinking about putting player A as the rows, heads or tails, and player B across the top, heads or tails. So if they both pick heads, player A wins $5. If player A chooses heads and player B chooses tails, player A loses $2. So in this cell, I'm going to put a -2 to reflect that. So this matrix is really reflecting what happens to player A. If player A wins, the number is positive. If player A loses, the number is negative. How about this one? If player A chooses tails and player B chooses heads, then player A loses $3. So that's player A chooses heads, player B chooses, player A chooses tails, player A chooses head. The game says player A loses $3. So I'm going to put -3 there. And the last one is player A is tails, player B chooses tails, player A wins $5. So I'm going to put a $5 here. All right, so this is the payoff matrix, it's called. It's really telling you what payoffs result based on some combination of events. All right, now the question is, what is the best strategy for each player? Should player A always choose heads, always choose tails? Should player A say, maybe I'm going to do 60% heads, 40% tails? And then player B is going to have their own strategy as well. So the way we're going to write this is set up a matrix for player A and player B. Okay, so let's say player A decides to do heads 60% and tails 40%. So this is the strategy for player A. Player B decides to go with heads 30% of the times and tails 70% of the time. Okay, now usually player A we're going to set up as a 1x2, and player B we're going to set up as 2x1. Sometimes we call this a row matrix because it's only one row, and sometimes we call this a column matrix because it's just one column. All right, and remember, this was the payoff matrix we're starting with. All right, so how do I figure out the expected payoff, let's say for player A? All right, so this is the game. You could think of this as like the definition of the game. Player A decides to go with this strategy. Player B is deciding to go to this strategy. Let's say they play many, many games. What would happen in the long run? What would be the expected payoff for player A? Would player A expect to win money over the long term? Lose money? Break even? Well, here's the way you calculate the expected payoff. We're going to do matrix multiplication, where you take matrix A times matrix P times matrix B. This is going to be the expected payoff. Remember, matrix A is the strategy matrix for player A. Matrix B is the strategy matrix for player B, and this P is the payoff matrix. Right, presumably both players have agreed to this payoff matrix. That's kind of like the way the game works, basically, right? All right, so let's do an example. All we have to do is multiply these matrices together using the methods that we just talked about. So let's do it. All right, first of all, can we multiply these matrices together? Are we allowed? Well, we're going to take the player A matrix times the payoff times the player B. All right, well, the player A matrix was a 1x2. The payoff matrix was a 2x2. All right, so let me write this out here. 1x2. So this is A times P. And then we're going to multiply it by B. B is a 2x1 matrix. All right, let's do this multiplication first. Are we allowed to do this multiplication? Yes, we are, because these two numbers in the middle are the same. What is the result when we do this multiplication? Well, I'm going to cross this out and this out. So the result here is going to be a 1x2 matrix. But then I'm going to multiply that by matrix B, which is a 2x1. Can I do that multiplication? Yes, I can. These numbers are the same. And when I do that, you could see that my answer is going to be a 1-by-1 matrix. Well, a 1-by-1 matrix is just one cell, one number, basically. This number is the expected payoff. If this number is positive, that's going to mean that we expect player A to gain or win money. If it's negative, that implies player A is going to lose money over the long run. So let's do the example here. All right, well, here was matrix A. Here was the payoff matrix. And here was matrix B. So let me write out, let's do the multiplication here. Let's do A times P to begin with. So let's do this part first. So when we do this part, this multiplication, it's going to be 0.6, 0.4, multiplying 5, -3, -2, 5. Okay? And I know my answer, let's double check the dimensions again. This is a 1-by-2 matrix. This is a 2-by-2 matrix. I'm going to cross these out. It means my answer is a 1-by-2 matrix. That means it's going to be 1 row and 2 columns. So I need answers to put in these boxes. Okay, so let me do this. I'm going to call this R1 here, and I'll call this C1, C2. So I'm going to calculate R1 times C1 like we did a few minutes ago. That's going to be 0.6 times 5 plus 0.4 times -3. Okay, so this is going to be, this is 3 plus -1.2. So this looks like 1.8. So in this box, I'm going to put 1.8. So this was R1 times C1. All right, let me keep going. I'm now going to do R1 times C2. And I'm going to put that answer here. Okay, well, row 1, so I'm going to take R1 and multiply it by C2. Okay, so it's going to be 0.6 times this -2. Then I'm going to come back and take 0.4 times that 5. All right, let's see. This is -1.2 plus 2. So that looks like 0.8. So I'm going to put a 0.8 here. All right, so that's the answer we came up with here. So A times P, we just figured out, gets us the answer of 1.8, 0.8. Now I'm going to multiply that by B. And remember, matrix B was this 0.3, 0.7. All right, so I'm going to take R1 here and multiply it by the C1. All right, so let's do it. Again, I'm going to check the dimensions. This is a 1-by-2, and I'm going to multiply it by a 2-by-1. Again, these middle numbers are the same, and my answer is just a 1-by-1. That just means it's just a single element, right? All right, so to answer that, I'm going to do R1 times C1. So when I do that, that's going to be 1.8 times 0.3 plus, now I got to take 0.8 times 0.7. 0.8 times 0.7. I'll work this out. Let's see, 1.8 times 0.3 is 0.54. And then 0.8 times 0.7 is 0.56. And if I add those together, I get 1.1. So this answer is 1.1. That's the payoff. That's my answer. What does that mean? Well, when we get 1.1 as an answer, it's the expected payoff based on these strategies. It really means player A should win $1.10 as an expected payoff. That means player A is really going to profit from this game. If we had come up with a negative number, that would mean player A would lose. And of course, that would mean player B would win. So a positive payoff means player A is going to come out ahead. A negative number means player A is going to end up losing in this particular game. All right, so the bottom line here is to find the expected payoff for a two-player game like this. You've got to take the matrices A times P times B. Work that out. This P is the payoff matrix. It's really based on the setup of the game. Matrix A is the strategy matrix for player A, right? That really is determined by player A, coming up with the probabilities of how they're going to play the game, and the same for player B is the strategy matrix. All right, let me go to the discussion board for a second. Actually, let's go to WebAssign. Why don't we do an example in WebAssign? Let me go to WebAssign, and let's do a couple of examples here. So let me go to the first example. This is the section 3. I'm sorry, this is the section 4.4 homework. And module 3 homework, right? We call it module 3, cover section 4.4. Let's go to problem 1. Problem 1 says calculate the expected payoff of the game. Here's the payoff matrix, P. Here is the strategy matrix for player R. And here is the strategy matrix for player C, let's call it. You could think of this as player A and player B if you want, right? We were using player A and player B, but they're using player R and player C. All right, so the expected payoff is defined as taking matrix R times P times C, right? This is the payoff matrix that we're given in the problem. Now, one comment here on this matrix C, when they put a little t there, they mean transpose. So really what they're trying to say is matrix C is really a column matrix. So really matrix C looks like this. So when they say C equals 0, 1, 0, 0, t, this t means transpose. What it says is take any rows and convert them into columns. That's what the t means. So I'm going to take this row matrix and convert it into this column matrix. All right, so let's do this multiplication. It looks kind of messy, but I think it's not going to turn out as bad as you might think. All right, first, let me write down the dimensions of these matrices because I got to check out, can I really do this multiplication? Well, R is 1 row by 4 columns. P is 4 rows, 4 columns. And the column matrix here is really 4 rows, 1 column. So let's do R times P to get started on this. Can we do this multiplication? Yes, these middle numbers are the same. And the answer when we do this is going to be 1 by 4. Then when we multiply it by matrix C, which is 4 by 1, these numbers are the same. And you can see our answer is going to be a 1 by 1 matrix. All right, so let's do it. I think we're confirming that it's okay to do this multiplication. So let's start out. So remember, the expected payoff is going to be taking R times P times C. But let's start off doing this R times P multiplication. All right, so let's do R times P. So we're going to take 0, 0, 0, 1 and multiply it by this P matrix. Okay, so the P matrix is 3, negative 1, negative 2, 3, 0, 0, 0, 2. And 3, negative 3, 1, 1. Okay, so let's work this out. Now I know that this is a 1 by 4 multiplying a 4 by 4. So I know my answer has to be a 1 by 4 matrix. So my answer is a 1 by 4. So it's going to be one row, and I need to come up with 4 numbers to put in these boxes. All right, well, I'm going to take R1 here and multiply it by C1 to get started. All right, so let's do it. R1 times C1. Here's the good news. These zeros in R1 are going to make the multiplication easy because it's going to be 0. I'm going to start here with 0 times 3. But of course, that's just a 0. I'm going to write it out just to show the multiplication. So I'm going to start out with 0 times 3, 0 plus 0 times negative 1, plus 0 times negative 2, plus 1 times 3. All right, well, this is a 0, a 0, a 0, and a 3. So I'm getting a 3 here. So this was R1 times C1. All right, well, let me do R1 times C2. All right, so I'm going to take R1 and multiply it by this column C2. But you can probably see I'm going to be multiplying zeros. So it's going to be a 0 plus a 0 plus a 0. And the only multiplication that's really going to matter is this 1 multiplying that 2. So this answer is just going to be a 2. So I'm going to put a 2 here. So this was row 1 times C2. All right, let me keep going. I'm going to do row 1 times column 3. And again, these zeros mean the only multiplication that matters is this 1 multiplying this negative 1. So this answer is going to be negative 1. I'm going to put that here. Okay, and let's do one last multiplication, R1 times C4. Again, there's going to be zeros, and then the 1 is going to multiply this 1. So I'm going to get a 1 out of that. So I'm going to put a 1 here. All right, so what we ended up with for this multiplication is 3, 2, negative 1, 1. Now we're going to multiply this by this column matrix, right? So C is this column matrix, which is 0, 1, 0, 0. Okay, let me fix that on the bottom here. That's not right. This is a 0 and a 0. All right, well, I'm just going to multiply the corresponding entries. So it's going to be 3 times 0 plus 2 times 1 plus negative 1 times 0 plus 1 times 0. Right? But that's going to be 0 plus 2 plus 0 plus 0. Final answer is 2. So the expected payoff here is 2. So this player R, in the long term, expects to win at this game, and the payoff would be 2. Let's say $2, for example. If this had been a negative number, it would tell me that R is going to lose money over the long term. Okay, so this is the way to figure out the expected payoff. You take, sometimes we write it as, depends on how we label the matrices, right? So sometimes in the textbook, they were showing A times P times B. Or you could write it as R times P times C. It doesn't matter what you label the strategy matrix if the result of multiplying these 3 matrices together. All right, let me do one more example here. Again, we'll find a payoff matrix. Let's go to number 2. Okay. Now, of course, when you go to do these examples in WebAssign, the numbers are randomized. So you'll end up seeing different numbers in your matrices, but it's going to be the same idea. All right, so why don't we start out? So the expected payoff here is going to be R times P times C. So let's start off with R times P. All right, so let me put R over here in front. 0, 0.5, 0, 0.5. Okay, so this is the R matrix here. I know this is 1 by 4, and I'm multiplying it by 4 by 4. So our answer is going to be a 1 by 4 matrix. All right, so our answer is going to be a 1 by 4, meaning we need numbers to put in these 4 boxes. All right, so let me take row 1 and multiply it by column 1. All right, I'll do it over here, row 1 times column 1. All right, well, I'm going to start off with 0 times -3 plus 0.5 times 1 plus 0 times 0 plus 0.5 times -1. All right, if I work this out, this is 0 plus 0.5 plus 0 plus -0.5. Well, that's a 0. So this entry is a 0. All right, let me do R1 times C2. All right, well, I can save a little bit of time because this entry is always going to be 0. This entry is always going to be 0. So when I do this, it's going to be 0 plus 0.5 times 2 plus 0 plus 0.5 times 3. I'm just multiplying the corresponding entries because this is the way you multiply matrices. All right, well, let me work this out. This is going to be 0 plus 1 plus 0 plus 1.5. So this looks like 2.5. So I'm going to put a 2.5 here. All right, let's keep going. R1 times C3. Again, this is going to be a 0 plus 0.5 times 3 plus 0 plus 0.5 times -3. All right, well, that's going to be 0 plus 1.5 plus 0 plus -1.5. So that works out to be a 0. So I'm going to put a 0 here. Last one, we'll do R1 times C4. So that's going to be 0 plus 0.5 times this -1 plus 0 plus 0.5 times this 2 down here. Work this out. This is 0 plus -0.5 plus 0 plus 1, which I think works out to be 0.5. So this is 0.5 here. All right, so we have this answer. Let's multiply that by the C matrix. So now we're going to do the final multiplication here. This answer we just came up with was 0, 2.5, 0, 0.5. And we're going to multiply this. Remember, we're going to transpose this and make this into a column matrix. So I'm going to write that as 0.5, 0.5, 0, 0. All right, now I'm going to multiply this row times this column. So when I do that, it's going to be 0 times 0.5. That's this entry times that entry, plus 2.5 times 0.5. That's this entry times that entry, plus 0 times 0, plus 0.5 times 0. All right, if I work this out, this is a 0. This is 1.25. This is 0. This is 0. I'm ending up with just 1.25. So the answer here is 1.25. Again, so player R would expect to profit from this game and win. We could think of it as $1.25. All right, folks, hope this is helpful as you're getting started. Oh, I want to go to the discussion board. Let me do that. So let me go to the discussion board, and I'll just show you the setup. All right, here's the instructions. It says develop your own two-player game, right? Imagine you're challenging a friend, and you can make up similar problems to the example we just looked at, but you're going to create your own payoff matrix. All right, so create your own payoff matrix as a 2x2 matrix. So for example, you might use the heads tails game, right? Where this is you and this is your friend, let's say. And you would come up with different payoffs to put here, right? You could make up the game yourself, okay? So it says the options for player A are on the left side. So let's call this player A, and we'll call this player B, just to be consistent. Okay. Then it says create your own strategy matrix for player A. It's a 1x2 matrix. So player A, maybe you're going to come up with a strategy matrix that says you're going to go with heads 70% and tails 30%, let's say. Remember, your game doesn't have to be heads or tails. You can make up your own game. And you're going to do the same thing for player B. Player B is going to be a 2x1 matrix like this. Maybe player B says, I'm going to play heads 20% and tails 80% of the time. Okay. So here's an example. If player A decides to go with the option represented by the first row with 75% probability and the second row with 25%, then matrix A would be 0.75, 0.25. Again, you're going to make these up, but these numbers should add to 1. Right? These probabilities should add up to 1. All right, then it says calculate the expected payoff using matrix operations. Well, for the expected payoff, you're going to multiply these matrices together. You're going to multiply A times, this is matrix P, we'll call it, right? So this is going to be A times P times B. You'll work out this multiplication. You're going to get a single number as your answer. That number is the expected payoff. Okay? If you want to enter matrices in your posting, you can do that. So if you go to the menu, and you'll see an icon that looks like a blue V on the editing. Here it is. If you could see it, let me mark it so you can see it here. This is the icon you'll see. You'll come down there. It'll say insert math equation, and you'll see that it allows you to select a matrix setup, and so you can enter matrices in your discussion board. Okay. All right, folks, let me know if there's any questions, and hope this is helpful as you're working in Module 3.